So in this session, we're going to have a detailed discussion on these data types and the operations that are allowed on that. So the whole point we're doing is because we wanted to make a mini project on finance manager, personal finance manager. So we in the previous class learned how to take an input from a user, and after that how to format it and how to output. If let's suppose we were taking input as the name and then we were greeting the user, okay, that's what we did so far. And then we started learning about these data types. In that we took the numeric data types first. So in the data types there were a lot of types that we saw that Python allows, and the first we saw numeric data types. So in that we saw two types of data, that is integer and float. So in the integer I said that these are represented in 2's complement in the computer's memory, and these float values are represented in the format called as IEEE 754 standard. And there are two standards to this. One is called a single precision and another is called a double precision standard. These are unnecessary details if you even don't know, but still you can be a programmer. So I just was answering why are they different data types. So on these integers and floats, then we said there are operations allowed on that. The operations we saw are called as arithmetic operators. Arithmetic operations. Okay, why are we studying this? Because as we said in the project, we'll first get an input name and probably then different streams of income. And the income will be either a float or an integer. And we'll have to see what are the operations allowed on that. Sometimes we need to add the income, we'll need to decrease or subtract the expenses. Let's start from there. We'll just do one thing. We'll make a small calculator sort of thing first, because we know about integers and floats and we know about the operations like addition, subtraction, division, multiplication, floor division, and then modulus exponentiation. So these are the operations that we have studied in the previous class. So let's first practice what we preached in the previous class, and we'll make a small calculator. So in the calculator what we'll do, the specification will be, so we'll take input two numbers. We'll take input two numbers and then we'll perform these operations on these two numbers. A simple thing will be made, and this calculator will help us to, because we have to do many operations on that income, and we'll be given income and expenses. We'll have to either add, subtract, multiply some things. That's why in order to have a grip on those things, we'll make a small calculator, okay, maybe dummy calculator. So let's move on to the coding window and we'll start the code. So again, if you see here, now this is my shell, and here I have the text editor. So first what I'll do is I'll create a directory, make directory of, let's suppose today's session 4th on Python. So I'll just create this directory, and session 4. Now I'll create the code. So today's first file that we are going to create is, let's call that calculator.py. I hope this is visible to everybody. Now you can see that the file has been created. So the first thing that we have to do is we'll take two numbers as an input. Okay, let me just disable this copilot so it does not give suggestions. So now if you can see, we'll write number 1. So we'll take a number 1 as input. So we'll say input, enter the first number. Okay, and this is the first number that we'll take, and then we'll define number 2. Again, we'll take input, enter the second number. Now I'll add these two numbers. First we'll perform the addition. So how to perform addition? Let's do this, number 1 plus number 2. Okay, let's store this in some result, or maybe addition. Okay, and addition, this is the assignment. Now let's suppose I'll print this sum of two numbers is, let's say this is the addition. This is our program. Okay, I hope that this is visible on the screen. So now let's run it in the terminal. So if you see over here on the terminal, I'll just delete this bash first. Let's kill this terminal, open a new one. Yes. So cd session 4. Okay, so here if you see, I have this calculator.py file over here. So now I want to run this. Let's suppose I want to run this. I'll write Python 3, and after that what I'll do is I'll run this program, that's calculator. So how I complete this, I'll just press tab over here. So if I press, I'll say calculator.py. So now here you can see that enter the first number. Let's suppose I'll enter the first number as 2 and I'll enter the second number as 1. Okay, so now question to Arshan. Arshan, what should be the output? Okay, so let's go and we'll check this. And if I just press the enter, you will see sum of two numbers is 21. The first bug that we saw. So why is this bug there? Can Nice. So what we have to do, we'll have to do typecasting. So the first thing that we'll have to do is typecasting. So how to typecast it? So we'll again go on this window and we'll write integer. Okay, so and then we'll write integer over here also.
Screen the coding. Yeah, now it's good.
Yes, thank you. So if you see over here, now you can see that I just typecasted these because you know that the input, this function returns a string. So now I just, if I entered even 2, it doesn't matter, it was a string. So when we perform plus operation, it just concatenate these two strings. So now here, as it was, the bug was caught that we saw that we have to typecast into integer. Now I am typecasting it into integer. So when I run this code now, so if I give the number as 2, now as let's suppose 3, now you can see that sum of two numbers is 5. Okay, so one more thing that I can do on top of this is that I can reduce the complexity of the code. As you can see, there are multiple lines. So what I can do is I can just write this addition instead of this addition writing it over here. So I'll just delete this because it's just unnecessary, because I'm just creating it and using it here. So I can make it compact like this. I'll just put this over here. It'll give me the same output. Okay, and there will be no change in the output, because here I was just creating a temporary variable. So in that temporary variable, I was first assigning that value and then I was summing it up. Okay, so now if I run the code, same code, if I run it, so you can see that there is no change in the result. Okay, but people can argue that what is the better style of code. Okay, here you can see that if the line was much longer, so it would have been like a bit clumsy. And one more thing is we had to add comments. So parallelly we must add comments. So here we'll write take two numbers as input. So this is what the comment is, and then here I'm printing it. So I will just add one more comment, print the sum. These are the comments. So now I can do one more thing over here. So instead of just writing this int num1 and num2, what I can do is I can just perform it over here. So int over here, and then I can again call int over there. Basically here you are composing the function. This is composition of the function that we have studied in the mathematical class. We saw what's called as composition of a function. So in that, if you see over here, so what you can do is, let's suppose if you have a function f and you have a function g takes some input, let's suppose x, and whatever the output of this function, it is taken input by this. So this we call as composition of functions. So as I said that this input is a function, okay, this integer is a function, okay, because we have a function, two functions. Now we have input function and we have integer function. Both of these are function. So this input, it takes some argument over here, okay, and then whatever the output of this input is, will give that output input to this. Okay, that's why we call it composition. So if you see, this is now developed by a mathematician. I told you that I'll frequently visit these shows. I'll show you that this language was developed by a mathematician. So you can clearly see that over here. So here we are doing the composition of the function. This statement over here, this basically is composition of the function. Is it clear? How is it composition? This line and this line, because we're composing two
Yes,
functions.
right. In fact, every language has this kind of feature. I think you can write.
Yes, you can have, but specifically here you will see these sort of things. So there also you can do it, but here explicitly you can identify those things. So you can write function within a function also. But here, let's suppose integer, if you see, there is not only typecasting, you have multiple features that will resemble the mathematics. I'll show you that even symbols resemble, like for all belongs to, and these things, they'll resemble all the mathematical set theory that we have. Okay, whatever
Yeah.
can be done in one language, that can be done in another language. So there is no question that this can't be done in another language. But it's just a design choice. How do we want to implement it? Now let's again print this thing. So I just converted this int over here. I'll just say num1 plus num2 over here. So now if I num1 plus num2, if I run the code, I hope that this should run without bugs. So here you can see the sum of two numbers is 34. Okay, so this is how you should write the code, and now you can just write the subtraction, and you can write multiplication, exponential. It will be a simple calculator for you people. Okay, and but the thing that I wanted to show you, the first thing is you can see that we can do these sort of things together. Now what can we do is we can do one more thing over here. Let's suppose we just want to prompt a user with one input. Let's suppose we'll say enter the numbers. We don't want to just say let's suppose enter first number, enter second. I just wanted to enter numbers. Okay, I want to enter numbers. So what I can do is, let's suppose, and then after that I wanted to sum them in somehow. Okay, so let's do that. Let's just comment out this code. So if I, let's suppose, ask the user enter two numbers, I'll just do this and remove this end part also, because now I'm taking multiple inputs from the user, that too with a single prompt. And sometimes in the code you will have to say enter your all income streams, wherever you get income from, enter your income. So user will just input multiple incomes. So if I just enter it here, let's suppose I'll just run this code now. So now you can say I'll enter 12, I'll enter 34, something. I enter two numbers. Okay, now what will happen is, so this num1, as it will collect the string. So you can see that with the numbers that were entered was 12 and 34. We somehow wanted a method, we somehow wanted a way by which I can split this. So this should be split into two separate variables. So I should be able to assign it to two separate variables. And for that, we have functions in Python. Okay, if you want to take multiple inputs, and in Python, how do we handle this? We have a function called split. You can just write dot split over here. Let's suppose now we have this num1. If I want to print num1, okay, so let's suppose you will see it as a string. Python 12 and let's put 23. So you can see this 12 and 23 got printed, but still it's a string. So if I want to convert it into number, so what I will do is I'll convert this num1. So num1 should be equal to num1 dot split. So now I'll split these two things into, by what is this split method? You can just go on the documentation and search for split. So split will split based on the separator. So here the separator space, I'm giving nothing. So this again is a function. So this over split is a function. It will split the coming input based on these spaces. So wherever we keep the space, it'll just split it out. Let's now just run the code that we. So here 12 and 23. So now you can see that it made it a list. So we'll see what list is. So now this got separated out. Now I can do something like this, num1 of 0 and num1 of 1. So now it will print these. Now I have access to these numbers separately. Okay, now still they are strings, so I wanted to convert them into int. So that's all. That's the one thing that we have to do also. So let's first do this. We'll again run this code. So over here, this is 12, this is 25. So this is 12 and 25 because this is num0 and this is num1. Okay, so still they are not integers. So now in order to convert them to int, I'll convert them into int like this. Okay, now I'm accessing these things separately. All of these concepts I'll introduce, what is the list, what are these things, but I just wanted to show you that there are ways in which we can split. So this is 12, oh sorry, something, because num1 is not there, I'll have to enter two numbers. That's why we have to test this 12 and 23. If I want to add them now, I just put add over here. You can see that I got the addition of these numbers. So now you saw the first method is a split. So now again I am using these variables. If you see this num1, let's suppose we don't have numbers. Let's take somebody's name, first name and last name. So how to split that even if we don't want to typecast? Okay, let's suppose I'll delete this code. I want to take input. Let's suppose name, which would give me the first name and the last name. So I will take his input, enter your name. So over here, if they enter, then the first thing is I want to split it. So but what you can do is you can do it in one line also. You can just write split on here. Okay, because we don't need to create two separate variables. So now you know that if it is split, let's call this as f name comma second name s name. Okay, so now what will happen is, because if I am giving two sort of these syllables, one is first name and the second is second name. So in that I want to assign them to two separate variables, that's first name and separate second name. That's what we read about multiple assignment. Okay, so here we'll do multiple assignment. The first thing is this line will run, it'll ask me for the input. I'll give the input the first name and the second name, and then I'll split by using this function. So what will split do? Split will assign the it'll split these two names, and that for the first name will be assigned to this first name and the second name will be assigned to the second name. And now I can print them. Okay, I can print the first name and the second name. First name comma second name. So let's run this code. Again, I have named this calculator. Let's call this as Ijaz Sadiq. Let's suppose this is the name. So now you can see that two separate things were printed, so Ijaz and Sadiq. Okay, we can just also print only one thing if we give two things also, because we won't be using, let's suppose this is ABC, some DEF, and you can see ABC is printed. So what's the point of showing you this is because you will need these sort of functionalities. So first, let's go back to the pad window so that I can summarize what we have studied so far. Going back to the so if you can see now what we have studied so far, we sort of learned how to take input. Okay, so we took how to take input, and then we bound that also. So something is there is binding. So we now took an input and bound that to some variable. Okay, after that we saw how to split this. So if we take multiple, how to deal with multiple inputs, how to deal with multiple inputs. Okay, you use the function that's split. This is the function that we'll use. Okay, dot split rather. So you'll have a statement and you will apply dot split onto that. And this split, if you want to see, you can just search on this documentation split function, and there you will see that signature of the function, where you will see that what is the input or what are the arguments or parameters that it takes. And we'll slowly build that. But here, in order to build an application, you must know all of these. I hope that this was clear. And then we also made a small calculator. So in that, what we said is we just took two inputs, and in that we wanted to add them, and similarly we could have subtracted them, divided them, and we could have completed the whole calculator. I hope that this is clear so far. Is it clear? Any questions? So we are slowly going to build all these functionalities, and then we'll put all the things together. Once we are done with all the things, we'll put them together. Now you have seen how to take an input and then how to basically greet. Okay, so now we have dealt with main two things. The first thing is we handled some numeric data. Okay, some in numeric we had integers and we had floats. Okay, and you saw the operations that are possible on these two things. And then now let's have some detailed discussion onto these strings, which I call as strings. Okay, let's have some discussion onto these. String basically is a set of characters. If you see, it is just a run of characters. I'll write run or set of characters. Not even set is not a perfect word for it, because set usually does not give you possibility of repetition, but here we can repeat the things also. So run of characters. So what is the character? So if we have a character A, this is a character. If we have underscore, this is a character. So a set of characters is called as a string. So in Python, if you see, you can define these strings in multiple ways. You can define the string in single quotes. Okay, let's suppose we can say how are you, something like this, in single quotes, or you can also put double quotes, or maybe triple quotes also. Okay, this is allowed in Python. So you can convert these. You can have these strings defined like this. Okay, string also there come in what we have sequential data type. So because there is a sequence, we have to respect the order. So it comes under sequential data type. Sequential data type. Okay, why? Because there is a sequence which we have to respect. Let's suppose if I have this name variable, it's a string. So if I call it, let's suppose Ijaz. Okay, now you can see that here this Ijaz, basically the word, the sequence of the word, these letters matter. So I cannot write, let's suppose I, J, A, Z, something like this. So it won't make sense to me. That's why it's called sequential. Okay, so where we have to respect some order. And now how it is stored? So you have to, because how C, C++ and Python store is entirely different. Okay, but there is a mechanism of how to store. So if you ask me about C, so C stores it as in the continuous run the memory. But in Python, it is not stored in the continuous run. So let's suppose if you see, if you ask me in the C, how does it store? It is stored in the array in continuous memory. So in C, it is stored like this. So A will be stored in the next memory location. I will be stored, then J, then A and Z, and then at the end we put a \0. So if you just print the location of individual characters over here. Okay, so what will happen is you will see that this order is respected. Let's suppose this has address 100. Okay, if let's suppose one of these characters take 4 bytes, let's say, and memory is something called as word addressable. Let's also have a discussion on this. What is word addressable, so that you get an idea what I mean by this. So let's suppose you have this RAM in your computer's memory. This is RAM, let's suppose. Okay, RAM will be made up of let's say flip-flops, and nowadays I think we have advanced structures by which we hold this memory. So now we have to make an address. We have to somehow, if we want to address, we have to give names to these locations. But what I said is, I said this memory is word addressable. What's the meaning of word addressable? That is, we don't address each bit, because memory is made of bits. Okay, you can hold one bit, or you can just have probably a run of bits, but here we don't have bit level addressing. We don't address the whole bit. The problem with that is, and in order to address one bit, we have to again keep an address for that. Okay, we have to have a file system, and we have to build all these tables, lookup tables, where we can see this. So that's what we have done, is we have made the memory word addressable. Usually word is of, let's suppose, 1 byte, or it can be of 2 bytes, 3 bytes, depends. If it's byte addressable, that means you are giving one address to 1 byte. So 1 byte is 8 bits. So 1 byte is equal to 8 bits. I'm saying that memory is word addressable. So by that I mean, let's suppose these are my 8 bits. Let's say each block is of 2 bits. This is my 8 bits, and this will be given one name. Okay, this will be given one address, and this address will be, let's suppose, 100. Now after that, so from here to here, this will be given address second. Okay, each one of this is called a word. In computer science, this is called as a word. Okay, now you understood what is the meaning of word addressable. So word can be of 1 byte, 2 bytes, 3 bytes, depends on the architecture, how you have defined it. So memory is word addressable. Once you define the word, I said 1 byte is equal to 8 bits. So if you have 8 bits, that's called 1 byte. Let's suppose our one word, that's also equal to 1 byte. But it depends on the architecture. It depends on the inventors, or depends on who are programs this. So they can also have, let's suppose, 2 bytes in one word. So usually the memory is word addressable. We have to give the names to these memories. So in order to retrieve some data, in order to store some data, and these things have to be given names, and this memory has to be given some names, and the names are given by each name is given to one word, and these names usually are some numbers. That's what I'm saying. So coming back to this, so what I'm saying, in C, usually if you store this A, let's suppose A is stored at 100. Now say each character takes 4 bytes. Okay, each character takes 4 bytes. Now if you just access this memory of I, you will get 104 over here. Okay, that's continuous run of memory now, because A took 4 bytes. So the address, in the initial address was 100, and after that when you check the address of I, it will be 104. Okay, for this it will be 108, just plus 4. Now let me answer the question, why does computer science people, they start with 0? You might have seen we do 0, what's called as 0 indexing. We'll see what indexing is, but here I wanted to answer this question, why do we start from 0? Okay, because it's mathematically easy. So now you have, let's suppose, this Ajaz word, Ajaz is over here, A-I-J-A-Z, and then we put a backslash 0 onto here. So I said that here it will be 100, this will be 104, this will be 108, 112, 116. Okay, now let's suppose there is a concept called as indexing or slicing. If I want to have a hold of this number, so this is at 0, 1, 2, 3, 4th index. Okay, usually if we start at 1, it will be at 5th index, 1, 2, 3, 4, 5. Please have a look over here. If many people, probably like almost all of you might not know the reason why do we start indexing with 0, because it has a reason, because we have the faster memory allocation, then for faster memory access rather. So how do we do that? Let's suppose you want to, this is called an array A, ARR. Let's suppose this is the memory. So now ARR is the address, it holds the address 100. This address 100 is with this ARR. When you, now you want to directly address this, you want directly retrieve this element. So element basic, this is 5th element. Okay, so if you had, and you know that each character basically takes 4 bytes. So what you can do is, so you can say the base address is 100 over here, then plus add. Where do you want to go? You want to go to the 5th element. So let's suppose I want to go to the 5th element. Okay, and each element basically takes how many? 4 bytes. So I can multiply it by 4. So you can see the base address is 100 plus 4 5s are 20. So this is 120. So now 120 is over here. So you will basically go to this location. Now what we'll have to do? We have to do then subtract one more thing. Subtract this. Subtract 4 more bytes. That's the reason being, if we have to subtract, then we'll come on this 116. So it was better. Let's do one thing. We'll not call it 5th element. Let's call it 4th element. So now the formula becomes base plus 4 multiplied by 4. So base address is 100, then plus 4 multiplied by 4 is 16. Then we'll directly go on to 116. Okay. So we have an advantage if we start with 0 indexing. So we don't need to subtract this, and we don't need to perform additional calculation. You just tell me I want to go index 4. I'll say base address plus howsoever many elements you want to go. Let's suppose 4 multiplied by number of bytes taken by number of bytes taken by each element. Okay, and this is the formulation that we directly use. Otherwise we have to do 4 minus 1 either. Whatever element you want to go, then subtract 1 from that. It will be an additional calculation. and you know that how frequently you access memory. If you just, let's suppose it takes 1 nanosecond only to perform that calculation. So it'll add up continuously, because let's suppose you perform thousands and millions of these access operations, load the data, and then store the data. And if you just could save that 1 millisecond by just not subtracting 1 from this, so it'll save a huge number of time. So that's why usually computer science people, they store they index these number from 0. So that is the reason why we have that's the reason why we have started indexing in C with zeros. How many of you got the clarity why we start indexing with 0?
Yeah, I think most of us are patient for Arshan only.
So here, let me just summarize it. We're studying about strings. So in that, I said how in the previous language like C, C++, how they store it. And then we saw some brief view about the memory structure. And then we saw the reason why is this indexing, why does it start from 0? Okay, now coming back to the strings. Okay, this string basically, I said how it is defined. The string is defined by using single quotes, by using double quotes, and sometimes by using triple quotes also, that you clearly saw. And now we'll see some treatment of these strings. So you can do many operations on these strings. Okay, so how these strings are stored, and you can have probably a detailed we can have detailed discussion on that, but it's not required how the Python stores them. And now let's directly go to this strings. So let's suppose we'll define a string. Now what is the memory view that you guys should have of the string? So this is the memory view that I made. If you define anything like this, let's suppose if I define hello, this is what should be in your head. Okay, if I define something, a is equal to hello. Okay, this is the view that you should get into your head. That's how we should define these strings. And now strings, they have different operations defined in them. Okay, the first operation is that you can concatenate these strings. Okay, there are different operations. Okay, and you can maybe repeat the strings by using the multiplication. Let's go to the coding window and maybe show you some of these. And after that, we'll see there are different functions that are also defined on this. There are two types of things now defined on strings. The first thing, actually, this operation is also a function. Okay, but here you see that we have these symbols, and then functions, we have to call them with the names. So these operations are concatenation. So if I define this, this is concatenation. And this I'll call as repetition. Okay, then we have some functions also in which we can do many things with the these strings. And then we have one more important one, that is slicing. Okay, these are the concepts that we'll have to study. And let's go to the code window and we'll showcase each of these. Let me start VS Code over here. So now you have this. Let's say we'll just clean this. Suppose you are entering this first name and the last name, and we'll split them. Okay, we have the same program. Let's not print it. Okay, so now what will this line do? It'll ask you for the first, and it'll ask you for the input, and you will give a name. Okay, then the first name will be stored in the first name, and the second name will be stored in the second name. So we can concatenate them together. We can put these two things together. I can just add these numbers. If I just want to print, I can do this: f name and plus s name, because I know that both of these are strings. So I'll append them back to back. That's called appending. So if you just run this program, so I'll just enter name. Let's suppose Musawwir. If you can see that Musawwir Khalid. Now you can see that they concatenated. This space was not respected. Okay. If I want to add space, so I get space is a string also. So I can just add plus space and then plus this. So again, if I just run this, this is A, B, C, D, E, F. So here you can see that now I add the space. So the first operation that you saw over here is called as concatenation. This is the first operation, and you can also multiply it with a number. So let's suppose I have this string f name. Let's multiply it with 2. Okay, let's now print it. You will see that it will be repeated 2 times. So let's just run this, enter the name. Now you can see this is repeated 2 times. Musawwir multiplied, this is Musawwir multiplied by 2. And these are 2 features which other languages don't give like directly. We have to implement it on our own. Let's suppose if you want a functionality like this, you have to maybe define a separate function, or maybe you have to do some navigation here and there, and you have to do something on your own. But here Python provides the functionality directly. If you want to concatenate 2 strings, you can directly add them. If you want to add repetition, and you can, but if you divide it, it will throw an error, because division is the thing that is not defined. Let's do it. You can see that the error was there because we have an unsupported operand. So over here, the division is not supported for this string. Okay, but still you can see that we got this error at the runtime that this was caught, and sometimes we can get such errors which won't be on caught, that we call as full semantic errors. I hope that this is clear. Now let's say what we want to do is, sometimes we assume a lot of things. So let's suppose we are making this file manager. We are making our what we named it, finance manager. Okay, personal finance manager. In that, you will not assume that the user will respect these things. Let's suppose we asked for the name for the user. What will user do is, user may give it in like pretty bad format. Let's say I'll ask for the name. I'll not use the split. Let's say, so I'll just ask enter your name. Okay, so let's say I'll just print that name. So over here, if you see, so let's suppose somebody, I put this space, 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 and then I'll say my name is, let's suppose, Musawwir, and then again space, space, space. So if you see, this was same printed in the same format. Here we put spaces, here we put spaces, because now the user is not respecting whatever we said, and we are assuming a lot of things. The user will be a good user and he will just give the name in the right format. But sometimes you will see that user puts a lot of spaces here and there, and we want to basically get rid of these spaces. If I want to print this name, let's suppose we'll call this hello, and so that it's visible, hello and name. We'll do the same. And now I'll put a lot of spaces. Okay, some space I'm putting. So I want to show you that if the user is being a little bad, he'll put spaces here and there. Now we'll have to basically take care of these things. So we cannot rely on that user will be like following every rule, and he'll be giving us the sort of things like this. So what we want to do is, if user gives some spaces on there and user gives some space over here, and maybe it can be a keyboard error, or maybe user is like that, he writes some name like this. So what we can do is, we have a function where we can just remove these spaces. Okay, that function is called strip. So if I just call this function fname dot strip, okay, so I'll call this function strip. So this is one functionality I'm now showing. So I said you that we have strings, and in strings we have operations like this concatenation, and then we had these repetition. Now we will go onto some functions, onto some things that we can do. So I said that we have this string. So if the string is ill formatted, I'll say ill formatted means like somebody puts spaces on that. How we can remove these spaces? So Python has an inbuilt function on these. So inbuilt function on strings. One of these is strip. So there are humongous number of functions. I just show some of them, and once you need them, you just type it on the Google, and there will be some functionality defined. If you don't have, then you will have to manually define the function. So what will strip do basically? So strip, if you have an error, let's suppose I had this string Musawwir, and then I had spaces on here, and I had spaces over here also. This was my string. So what I want to do is, I want to strip these spaces. I want to get rid of these spaces. I can call strip function. So now let's give this name. So if I run this, and this is space, 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 some space. Now still you can see that these spaces were stripped off. Okay, we removed these spaces. You can see that on the terminal. Okay, this is the one functionality. Now let's suppose we won't assume that we'll get the first letter as capital, okay, and we'll get others letter as small, and it can be in any other way. So let's suppose I was asked the name. So if I gave my name like this, okay, it is still putting the first letter as lowercase. What if I want to make it uppercase? So what I can do for that is, I'll just call one more function. Okay, now it's becoming a little tedious, so I'll just call this strip separately on the fname to have the best coding rather style, or best coding etiquettes, ethics, whatever you call them. For fname, the first will strip. If you have put some additional spaces, we'll strip them. And then what we'll do is, we'll also do capitalize. There's a function capitalize. Okay, so if I call this, so what it'll do is, it'll make the first letter as capital letter. Okay, now let's run that again. Now you can see that the first letter was made as caps, it was made as uppercase. So this is the function capitalized. So why to get these all functions? So you just go to the Python documentation, docs.python.org, and there you'll find string data type, and if you click on that, and after that you will find a lot of functionalities that is supported by this string. So there are questions. Let me just pause the recording and we'll take the question. So Arshan asked a really good question. So how is this expression evaluated? These are called expressions. So if you see over here, so this is an expression. So what we do is, anything that is the first thing here you see in the assignment. So I said you that the computer's view, you should have memory like this. There is a computer's memory like this. So what we will do, if you have this assignment, go on the right hand side first. So if you go right hand side, this is the right hand side. Now what you will do is, you will say fname. So fname, let's suppose, was ABC like this. So space space ABC space space. This was our fname. So then it will call this dot strip. So it will go in this order. It will call dot strip, so it will just strip away these things. Okay, this is now the string, this is computer's memory, this is now the string, and after that it will call this capitalize. This is the order. The first thing is, this will be applied, and then this capitalize will be applied. So now capitalize will make this letter as capital. Okay, and then it will go to this equal to sign. It will assign This I call as binding. So it will bind this to a variable which we named as fname. This is what will happen in computer's memory. So this is evaluate first. If there is an assignment statement, we'll go on the right hand side of that. So once we are on the right hand side, and we'll now basically evaluate this expression from left to right. Okay, but once we're evaluating, we'll go from right to left. Just know the order. First, we'll go from right to left if there is an assignment. Okay, as we have a is equal, then we have some expression. Okay, we'll go from right to left. We'll start from right and then go towards left. But once we are evaluating this expression, evaluation goes from left to right. Is it clear? Is the order of execution clear? This is basically called precedence order sometimes. If there are different multiple operations, what precedence is given?
There is a question. Does Python also follow the same rules for associativity and the precedence, or same as the C language or C++?
Yes. For the arithmetic operators and these things, they follow the same rules. Let's suppose now we have arithmetic operator. There's an expression 3 plus 4 multiplied by 6 divided by 5, something like this. So it again goes from left to right. Okay, it goes from left to right. Now it gives the precedence order. Okay, now let's suppose it sees this plus operator first. It'll wait and it'll say, okay, this is multiplication. It basically makes a parse tree. So during parsing, it makes parse tree, and that's where we define this precedence order. That's called the order of precedence. It is almost same as C. I'm saying almost because maybe as there are additional operations that are defined that are not there in C. Okay, that's how the precedence is. Probably we can learn our precedence also. And if you just want to see what is the exact precedence, you can just go to the documentation and see what is the order of these operations. Okay, and in the associativity also they follow the similar rules, because mathematics, if you do it in C and if you do it in Python, they should give the same result. That's why for these arithmetic operators and even logical relation operator that we are going to see, so they follow something called as order of precedence. So what will be evaluated first and what will be evaluated later. I hope that Arshan, you got the answer to your question. So now you saw the strings. The thing is, string is a data type, and in that data type, we saw that there are some operations allowed, that is concatenation and the repetition. And now there are some functions also allowed. The functions that we saw, the first thing we saw is you can strip the things, and then you can also capitalize the things. Okay, now if you have a name, you can give the title also. Let's suppose I am entering a name, I am entering the first name and the last name, and I want to give them the title. So there is a function dot title. What does this dot title do? Let's suppose I'll enter my first name and the last name. So let's suppose I'll enter like this. Okay. So if I call this function dot title now, so it will capitalize the first letter. It will make it like a title. So it will capitalize it like this. And these two letters will be made in capitalized. And there are a lot of functions that are available. And there are I'll just mention few of them which probably you might find useful. And one is to uppercase, or that's called to lower. This makes everything lowercase. And dot upper, this makes everything uppercase. Okay, and split, I said join, you can join two things together. I'll just paste a code snippet so that I'll demonstrate some functionalities of this. I'll just paste a code snippet onto this VS Code. See over here, the first thing is I have this name Alice. I hope that the screen is visible for you guys. Okay, I have this name Alice, and then message for the Alice is hello world. The first thing I want to print is what's the type of this name. As you know that this will be type string. Okay, then I have defined this one more string as hello world. Okay, so operation is defined, so I'll just close this. I'll just basically delete this because this is slicing. We'll get to slicing after that. And let's do one thing. Let's call this S without slicing. So what I'm doing is, the first thing is I'm saying length of S. So this will return the length of S. Okay, length basically means how many characters are present in there. So S dot upper means this will be this hello world. Okay, now S dot lower, it will convert into lowercase. Okay, S dot replace, this replace is also a function. You can replace with world with Python. Okay, it will just search first. So this replace function, it will do the searching onto that whole string, and wherever it find the world, it will replace that into Python. And this, if you see f dot split, so split, now you see this argument is comma. So it will basically split based on the comma. Wherever it sees the comma, it will split, not based on the space. So before this, we used write dot split without anything in between. So this was basically, if you see space, then split it. So now we have put an argument like this, comma over here. Wherever you see the comma, then split this. Okay, and at the end we have joined these two things. The dot join, join this and then hello and the world, and you can join this, and basically hello will be this thing will be joined with hello and world. Let's see this. Let's see each of this output. Okay, so let's comment out this code. I'll comment and we'll see. Let's suppose we'll print this length. Okay, so length expected is what is the length of the string. So we have string, so string is this hello world. Okay, so just let's run this program. So you see this class string because this is the type, print type name, so this is of class string, and here you saw the length is 13. Now we'll see the uppercase because as you can clearly see that this hello world is not in the full uppercase. We'll just print, comment out this length, we'll print this uppercase. You will see that hello world, basically this thing will get printed. I just wanted to show you it here, over here. So you can see that this got printed. Now I want to print it in the lowercase. I hope that you guys will agree that now it will create lowercase from it. So here if I run this, so now this is lowercase hello world. Similarly I can replace. So okay, if I just print replaced, the world will be replaced now with Python. Now you see how we call this. S is basically this hello, and now replace does, it will first check where is this world and it will replace it with Python. Let's run it. You can see there hello Python. This world got replaced with Python. Okay, now split, we showed it, but one important thing over here is we are splitting based on this comma. Split based on the comma. You can see that this hello world contains this comma over here. Okay, this is the comma that is in the hello world. So now the split will be based on this comma. Okay, now you can see this. If I want to print the split, you'll see a list will get printed. Okay, and similarly if I want to join, this with this hello and world, you can see, let's suppose we'll just print joined, and there are a lot of methods like this defined, and you'll have to go to the documentation in order to see all the functionalities. You can see this hello world. Okay, so now going back, we have somehow covered strings in, I will say, a pretty much good depth, so that you get the idea that we have operations defined on that and we have functions defined on that. Whenever you have some additional functionality that you want to see, just check for the documentation. There are hundreds of methods that define the strings. So now we'll go on to one more concept important, that's called as slicing. Okay, slicing is an important feature that Python gives directly. So what is the meaning of slicing? So in that I said you that whenever you see a string, you make a map like this. So if I see this hello world, something like this, let's say. Okay, so now this is an index. This string basically is an index data type. We're giving indices to each of these things, and indices start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can access one character. So how do we access this? So let's suppose this is my string. I have this, let's suppose name, and then I called it hello world, like this, hello world. This is the picture that should be in your head. So now the first concept that is there is accessing. How do we access the elements? Okay, you can have randomized access. This is called as randomized access. In randomized access, what we'll do is, let's suppose you want this 6th character, or maybe in terms of computer science you want this 5th character. You can just write name, and in the braces you'll write this 5, and this will return W. Okay, let's just do it on this, let's suppose on the coding window we'll do it, so that this is clear to you. Just showing you the coding screen again. These are pretty basic concepts, but I don't want to leave anything for the toss. So let's suppose we have this string hello world over here. So this is our string. So if I want to print, let's call this print and S, and I can print, like, let's suppose 5th or maybe 4th character, say. So if I print this, like save this, print over, you can see that O got printed because this is 0, 1, 2, 3, and 4. This is the 4th character. Okay, so this is one, I can just access the character, randomized access. I can just go in the middle and access the character. And similarly I can do, let's suppose 6. If there is 6 character, I'll just go and I'll just print it. It got printed. I don't know if I've saved it. I need to save it first. I think something is happening. It's printing something though. Okay, bug. Let's see. Sometimes H is printing 4. Oh, okay. 6 is space. 6 is this. That's when nothing got printed. Actually, it was printing, but it was space. So 7, if I print, now it should be W then. Yes. So 6th basically is this character. That was space over here. So now you can have negative indices also. So if I print -1, So what will happen is, so -1 will be basically this character, the last character. This is called as negative indexing. Okay, you saw this. Okay, let me just shift back to there and I'll just negative index it also. So as you saw, this is 0, 1, 2, 3, 4, 5, 6, 7, and 9. So here we have -1, -2, -3, -4, and so on. Okay, so if we come up backwards, so from backwards in Python, we give what's called as negative indices. So this is called as positive indices, and this is my negative indexing. Negative indexing. Okay, so if you want to go from the backwards, you just need to write -1, -2. It is, again, it's programmatically heavy for the machines. Let's suppose if you do this -1, it has to evaluate a lot of things. Okay, but as I said, the design philosophy of Python is ease of programming. We don't care how do we have to compromise the efficiency. We'll anyway go on the minus and it will evaluate internally. It will take some more time, but here the philosophy is ease of programming. So okay, that's the reason we're giving negative indexing also. So one more concept is that we have to talk about is slicing. So what is the slice? Now you can just take a slice, a subset of these things. So there are two concepts. One is called as substring and one is called as subsequence. Okay, these are pretty two different things. So what is a substring and what is a subsequence? Let's see this. Let's suppose we have this A, B, call it apple. Say I will take a string apple. Okay, if you have this apple, let's suppose you want to take, you will take this A and you will take this P and you will take this P. You take the continuous chunk of maybe letters. Okay, you take this continuous chunk A, P, P, and you take this. So this over here I can call it a substring. Okay, because it's taking continuous. Let's suppose now if we take A, L, and E. So I missed the P's in between. I can call this a subsequence. So again, both of these are subsets in some way of this apple. So this app is also a subset because it is derived from here. And now this ALE is also a subset I'll call, but now the difference here is in between you are not leaving any letters. So if it's such case, so we call it a substring. This we call it a subsequence. Why am I telling you this? Because in the subsequent lectures probably we'll solve some problems. Okay, how many substrings are possible, or is this a subsequence? So there's a famous problem called as least common subsequence. Okay, this is the most common problem, and there we'll have to find subsequences, not substrings. Okay, so now how do we do slicing? So in slicing, you saw that accessing, we did this. We had this square braces and we put, let's suppose, some number over here. We did, let's suppose, s of 5. So it gave me the, I'll call this, let's suppose, sixth letter in the string. Now what I do is, if I want a slice of the string, that's why it's called slicing. If I have this hello world, and now you know that this is the structure, and if I want to just get over from here to here, if I want to get it, so I know this is from 0, 1, 2, 3, and 4. So what I'll do is I'll say this is my S, and I'll put S, and this is the start index, and then colon, and this is the end index. So start index here is 0. Okay, end index should be 4, but it excludes end index. That's where we learned the concept of intervals. So this is basically an semi-open interval. So here I'll have to write 5 over here because it will leave this part. So it will take 0, 1, 2, 3, and 4, and it will leave the 5. Let's test that on the coding window and we'll see it. So let's say I want from 0 to, let's suppose, 5. So it will take 0, 1, 2, 3, and 4. So if I just print it, you can see that it took 5 letters: 0, 1, 2, 3, and 4. Okay, if I just print 0 is to 5, so this tells me take it from 0 till 4 and exclude 5 basically. Okay, give me the first 5 letters, from the string hello world. Okay, now what is the format? So format is like this. So you have string, so I'll just comment it first. So you have string, and in that string you will first write these curly braces, and then you will write start, and then is to, basically colon, and you write end, and then you write step size. By default the step size is 1. What is the meaning of step size? So if you take, let's suppose, this S, 0 is to 5 is to 1. So what will it do is it will first take 0th character, and then it will add 0 plus 1. So then it will take first character, then second, then third, fourth, and once it sees fifth, it will exclude it. So if I otherwise write, let's say I write 2 over here. So what will it do is it will take 0, then 2, then 4. Okay, that is the step size over here. Let's take the step size. Now let's say I'll just put 1. So 1 or nothing, it means the same thing. So it will print again the hello, same thing will be printed. But what if I write 2 over here? Now it will jump 2 characters. you can see that it printed H, then left E, then printed LO, printed L, and again left the next L, printed O. Okay, so let's suppose we'll print. So what if I print this? What if I said this and this? I'll just put these two here. So it'll print whole the thing. Okay, so let's suppose we'll see it over here. So it printed the whole thing. Again coming back over here. So we had this S. So if I write nothing in the first index, I'll put S2. It'll take it from 0. Take it from 0. If I write and let's suppose 5. So this is by default 0. Now if I write nothing over here, that it'll take by default 1. So let's suppose I took till 7. So it'll automatically fill this with 0. Okay, you can see that H is printed, and then till this comma and probably space also. So let's suppose now if I gave nothing on here, I gave let's suppose 5th. So it'll take from the 5th character, it'll print everything. Okay. So if I just print it, you'll see that from the 5th, from comma, it printed everything. So if you do not write anything, so let's suppose from the start, it'll take everything. Then at the end, if you don't write anything, it'll take everything till the end. If you do not write a step size, it'll by default take 1. So again, just remember the syntax. So if this is the string, so then what we'll have? We'll have start, and then we'll have end, then we'll have the step size. Okay, I hope this is clear also. Is it clear? Any questions? I'll pause here for maybe 30 seconds or so.
Please give the example of not operator.
Okay. Completion, for the sake of completion. Okay, yes. So what not operation does is, I'll just close this. This is not operation. So if it just takes one expression, this is the unary operator. So it takes expression. So again, this expression should evaluate to either true or false. So this should evaluate to true or false. True or false. So when you apply this not, it will just negate the thing. If this expression was true, it will make it false. If it was false, it will make it true. So that's how the not operates. So that if you see the truth table, so you just have this expression 1, and from this you have this not operation applied onto this. This is true or false, so it will make it false and true. This is again heavily used many other times. Okay, if you want to evaluate these sort of things, and in order to do this, in order to have this, let's suppose and or, okay, and maybe not. So you can use the whole of this Boolean algebra. With the different algebra that is defined in this, that's called a Boolean algebra, and people do study in this discrete logic design. If you have an expression like this, let's suppose you have expression 1, then you are saying and, say and. Okay, let me write it like simply. So I'll write and like this. I'll write or like this. I'll write not like, let's suppose like this. So if I have A and B or C, not some D and F, something like this. So if I write a huge expression, so you can simplify this expression by using this Boolean algebra. Okay, in Boolean algebra, 2 important famous laws are De Morgan's laws. Okay, so I'll just name them over here. So just look it up what De Morgan's laws are. So by using these laws, and then if it is more complex, you use what's called as K maps also. So basically, in order to minimize this, so sometimes, because let's suppose you have many number of conditions, you have this A and B or C, D. So if you could somehow minimize this expression or optimize this, and it only evaluates to A or F, something like this. So the whole expression basically boils down to this. So it is better to only perform this, not to give rather your computer more hard time so that it evaluates the whole expression. It's sometimes better to use Boolean algebra in order to minimize these expressions. Okay, and what I say is, I said this, that you should know about De Morgan's laws. If it is a huge thing, you also should know about Carnot maps. There is something called as POS and SOPs. Okay, product of sums and sums of products. Okay, over here, like if you have these, I hope that you guys have went through digital logic design. This is not for Arshan probably, but Arshan, I am just giving the breadcrumbs how to minimize these expressions. If you have a huge expressions and with and or and nots, so how you can evaluate this? So you can evaluate this by using these things, but you can just have this, and you can use this De Morgan's law and K-maps, and you can just minimize the expression. Okay, this process called as minimization. And good programmers does minimize. If you see a lot of these operators, lot of logical operators, then you can see, okay, in order to do this, there must be some minimized expression, which is basically equivalent. These two things should be equivalent. Okay, if they're equivalent, it's better to write the minimized expression. Is it clear?
Please don't focus on this more, because otherwise I need to go back my college and take 2 semester fee back and give that to you. Because what you are saying is this is giving me like that feeling. Oh, what I was missing. I just remember what she was talking, but now I get to know what was that really. So I think I need to give you 2 semester fee that they took from me.
Yes, 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 yes. In the need of money. Startup is in the need of. Before going to bitwise operators, I would like to take one more thing, because how these numbers are represented. Let's suppose I said to this integer. So if we have integers in that, if I define something, this x is equal 10. Okay, so this will give me x is equal 10. Let's go to the coding window and let me show you there. Okay, let's go over here. I'll just clean the whole code. Let's suppose x is equal 10. So if I just print this x, so if I just press Control S over here, so you can see that this 10 got printed. So I said that let's suppose if I print something, if I wrote a symbol like this, let's suppose I wrote 10 at the rate something like this, 10. What should get printed? Mahmood, what do you think?
I think error.
Okay, if we just run it, there's an error. Obviously, let's suppose I'll put something like this. So if I say 101, what should get printed?
I think again error.
Voila, this is 1001. Why does it happen? Because Python allows you to introduce these lowercase, these underscores to in order to, let's suppose you want to write 1 million, so you'll write something like this, 1 million like this. Instead of commas, you can put this so that you can read the number clearly. So this Python does allow this. Okay.
Yes.
So let's suppose I'll just turn it. You can see that 1 million got printed. This is for the readability purposes. Ease of programming. Philosophy is ease of programming. So you can see that ease of programming over here. If I want to read the numbers clearly, I can read it like this. Okay. Tell me one more thing. So if I write, let's suppose some A10, what should get printed? What should be printed?
I think error.
Yes, right. Now if I write B, let's suppose over here, what should get printed?
Error again.
Say I write 010, what should be printed?
It should be okay 010.
It is again an error. Okay, so let's suppose if I write 0B10.
Oh, I think now maybe this is the other notation, maybe that hex or something. Is it or?
So let's see. Over here you can see the 2 got printed.
Mhm.
This is binary representation. You can represent numbers with
Oh,
binary. Just
yes,
add this
yes.
prefix 0B.
Wow.
Okay, so you can just write it like this. So if you now want to print this, so you can see 2. If I want to print, let's suppose 7, 111. So if I just save this, if I print this is 7. Python also does allow you this, and even C also allows you this. C and C++ also, they allow you this. Now if I write 0x, this is now hexadecimal. This is 273 in hexadecimal. Oh, sorry. So can you see over here? I just added the 0x. So this 0x basically, again, this is hexadecimal. If I print, let's suppose if I wrote something 0x1a. So you know the hexadecimal number system.
Yeah.
How many of you know this number system? I almost everybody knows. So
Should
if I print this, this will be 273 will be printed. So if I just say 1a, let's suppose again under a, I'll just save this 426. Now octal is also printed. You can also print octal. So in octal you write 0 and O. So if you have to print octal 0 and small o. But octal does not support a, so you must have symbols only from 0 to 7, 0 to 7. 1, 2, 3, let's suppose. So now if I run this is 83. This is how you can write, and sometimes it's better to use these octal symbols. Why? Yes, sometimes hexadecimal symbols are used for this memory addressing, and you will see many Python code being represented like this. Okay, and there are functions also. If you want to convert a binary into a decimal into binary, there are functions like bin. Let's suppose you have this number 10, and you want to convert it into binary, so you can just call bin. Again, philosophy is ease of programming. So programmer should be chill madi. Then if you see, this is binary. Hexadecimal HEX. Okay, if I just run this, it will be converted into hexadecimal.
Yeah, I think this is used to send if you want to use some serial programming to send the signals.
That's how addresses are read basically. So addresses are read in this way.
Yeah.
So now I'll just paste a code over here. You can see that I have almost covered in here. So this is a binary number. Okay, this is the hexadecimal number. This is an octal number. And if you want to convert, so this we have these functions bin, hexa, octal. And now if I print this program, and everything should be quite nice and smooth. You can see that clearly over here on the screen. Binary 13, and then hexadecimal we have this, and this is octal, and this is our decimal. This is again binary, hexadecimal, whatever there is. So this was one additional thing that I wanted to show you, that you can define the numbers in different number systems. Okay, if you guys know the number system, you will have got the idea how why in Python, and also other languages also support this. Okay, sometimes people might feel this is invalid, but this is not invalid. Okay, I hope you got some clarity on these things. Let me close the recording and let me take some questions if you have any.